Hello, let's continue our Sudoku adventure with Allsorts by Gene. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We just have circles in the grid. Any digit in a circle has to be odd. So 1, 3, or 5 in the circles. We have squares. Any digit in a square has to be even. So 2, 4, or 6. The way I remember that is circles look like an O for odd, and squares are the other one, or if you prefer, have an even number of sides. In addition to that, any shape in the grid, a circle, a square, or a star, all of the shapes, and it doesn't matter what the shape is, they are the sum of two of their up to four orthogonal neighbors. So this star, for example, has these four neighbors. It's going to be the sum of two of them, any two. So if this was, say, a 5, this could be 2, 3, and then 6, 4. And we just say, hey, this 5, we pick two of the neighbors, 2 and 3, that does sum to 5. So as long as any two of the neighbors sum to that digit, we're good. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so I guess the first thing to note is that shapes can't be a 1. Can they be a 2? Well, let's think about the odd ones first. So the odd ones are 1, 3, or 5. I don't think they can be a 1, because then, when you're summing two cells, that's going to sum to at least 2, no matter what you do. And so these are all from 3, 5, making a bunch of 3, 5 pairs. A bunch. This pair and this pair. And these two are the same digit. Now, for the evens, I don't think we can add to 2. In a lot of these, at least. Well, this one's next to a 3 or a 5, but that doesn't mean we have to use it. But anyway, even if we didn't use this one, the sum of these two is actually at least 3. So anyway, can any of these actually be 2? The only way I think this one could be 2. If we put a 1 here and a 1 here. Okay. But this one, can this one be a 2? Oh, 1 here and a 1 here? Yeah. So this one can't be, because we can't put a 1 there. And a 1. Okay, yeah. There's no way to do 2 1s. Oh, no, there is. 1 here and 1 here. The only reason that doesn't work is there's a square here. So this normally could be a 2, but instead it's limited to 4, 6. This one is probably not using that 4, 6. I mean, I guess we could do 4 plus 2, but either way, that would make it minimum 6. And we can't do 1, 1 here. So this is also 4, 6. Now this one, I believe, could do 1, 1 in a few ways. So I think these are all 2, 4, 6. Now the star is not forced to be even or odd, but it definitely can't be a 1. But I do believe it could be a 2. Yeah, like a 1, 1 here. Okay. Now, 1s are in short supply. We only have 6 of them, so we got to be careful about that. But I think we should think about these 3, 5 pairs and the 4, 6 pairs. So let's start with this column, actually, with this 3, 5. They share this digit, but they don't have to use it for the sum, but they share it. The 3 is going to have to be 1 plus 2 in some way. Now, this juxtaposition is interesting. This can't be let's see. It's hard that because it only uses 2. So what I'm thinking about is if this cell used these two to sum to it, then this one doesn't use both of these, because we know these add to this one, which is a different digit than this one. But it's going to have to use one of them. So one of these is a 1 or a 2. At least. And if this was a 1, 2 pair, we could still add to 5 by doing 4 and 1. So I'm not sure what to do with that. We have this 4, 6 pair. Now, I don't know, the availability of 1 really makes it too easy to sum to some of these things. One of these is a 4. Okay, one of these is a 4, 6. So this, okay. This cell here is definitely using one of these two. So even if it used the lower of them, well, if this was a 1, then we could do 1, 3 adding to 4. Ah, shoot. I don't think I can, discount that, can I? Well, I can say that if this was a 1, then neither of these are a 1, but this definitely needs a 1 next to it. One of these three is a 1, and one of them is a 2. And so that would force this to be a 1, but that seems perfectly reasonable because we want this to be 3 or 5 also. And I'm kind of just like assuming like, okay, well, we know one of these is a 3, so it's going to have to see a 1 and a 2, but this doesn't have to be the 3. This could be the 3, and that could be the 3. If this was a 3, this would be a 1-2 pair. And then this would be a 3. And this could be a 1-2 pair, so this would be a 1-2. But that seems to work okay. I don't know. So like 1-2 here with a 1-2 here. I don't see like an immediate reason that's broken there. I mean, but it might not be the solution. Okay. I don't know how we're getting into this puzzle. It's got to have to do with these pairs. One of these is a 4. 4 is going to have to be 1 plus 3. Or I don't think 2 plus 2 is possible for either of these, is it? Well, I could. I could do a 2 here and a 2 here. Make this... No, that's not right. These 3 cells. Right. So yeah, it's going to be... If this was a 4, the 1-3 pair goes exactly here. If this was a 4, then this is 1 and this is 3. Is that the only option? So if this was the 4, from these I need to add to 4. So I got to do a 1-3 pair here. That's the only option. If this was the 4, then this is 1 and that's 3. So... Oh, and then that's an issue. Okay. Right, I had to take it kind of a step further than I was before. So one of these is a 4, right? If this is a 4, we can definitely do it. A 1-3 pair here, that works. If this is the 4, we have to use 2 of these. We're not going to use this one, which is a 6. So this is a 1-3 pair, forcing this to be a 1 and this to be a 3. But if this is a 3, then from these we need to add to 3 with a 1-2 pair. But none of them can be 1 anymore because the 1's right there. Therefore, this is the 4 and this is the 6. And then this is our 1-3 pair. Now what? Good question. So these add to 6. If we used this one, this would be a 2. Okay, so let's write it out. If we used... This has a 6. So if we used these 2, we'd have a 2. We cannot use these 2 to add to 6. If we use these 2, then it can be... We can't do 3-3, so it would be 5-1. So this is a 1 or a 2, which means this cannot be a 3, because if it was a 3, we'd need a 1-2 pair here, and we can't now. So that's a 5, that's a 3, and that's a 5. That gives us the 1 and the 2 and the 4, and the 3 and the 6. Very nice. Okay, this is kind of small. So what is this? This is the 1 and the 4, and then up here we need the 2 and the 5. Okay. So this top band just finished. So this 3 needs a 2, so the 2 goes there. Now this 5, well, what is this pair here? This is 4-6. So we can't use these 2 to add to 5. They're both even. This is going to have to be odd, right? So 1 or 3. We could do a 2-3 pair here, or we could do a 4-1 here. So we don't know how that resolves. How about this 4? I don't know if we can... Can we use the 2? Okay, we cannot do 2 plus 2, because this 2 actually takes 2 out of all of these through the box in the row. So we're going to do 1 plus 3. And the 1 can't go here. And we can't do a 1-3 pair here. So this ends up being the 3. Because we know these are 1-3-6. Okay, well, that actually makes it easier. So we know the 1-3 pair goes like this. And this is the 3, this is the 1, this is the 3. Okay, so over here we need a 1 and 5. So that's 1, that's 5. Then over here we need 2, 4, 6. It's not 2, that's not 4. So we know the 5 isn't being used for the sum. The 4, 6 isn't going to work either. So this 2, 4 is the sum of these two. So it's not going to be the 2. So this is 4, this is 2, this is 6. And then 4, oops, and the 4 is going to be 2 plus 2 like that. Perfect. So this is a 1. This pair is a 3-4. This pair is a 5-6. Here we need a 3-5, and here we need a 1-2, and that's resolved. So how are we doing this guy? Good question. So if this was a... Okay, let me highlight. We're using these digits to add to 5 or 6. If we wanted to add to 5, we'd have to make this a 3. So we'd go 5, 3. That seems to work. If we wanted to add to 6, how would we do it? We can't do 1, 5. We can't do 2, 4. We can't do 3, 3. So no, yeah. So it is 5 with a 3 here. And that solves. 4, 6, and we're done. All right. Very nice puzzle, Gene. I enjoyed that. Yeah, I was kind of a little bit stuck on how to get started for a while, but then I realized it was the interaction between this 3-5 pair and this 4-6 pair. We kind of had to analyze where the 4 went, which wasn't my first instinct, obviously, but that worked out very nicely. All right, cool. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.